Today we're going to be talking about our Unit 2B. We're going to review everything about zeros of polynomials and put together our cheat sheet for the test. All right. So initially we started by talking about what a zero of a function is, right? And the zero of a function is zeros of functions are values of x that make the polynomial function equal to 0. All right. So if we have a polynomial function, any polynomial function, whatever makes that function equal to 0, that is a zero of that function. We also talked about some alternate names for zeros. Other names for zeros in various scenarios are, other names, that's what I meant to write. Other names for zeros are roots, x-intercepts, and we didn't explicitly talk about it, but solutions are also another name for zeros, finding the solutions to equations. So those are a few of the things that we talked about, how we introduce zeros, all right? So to find the total number of zeros that a polynomial has, the total number of zeros is always going to be the degree of the polynomial, okay? So if we have a polynomial function, for example, that is of degree, let's say we have 6x to the fourth plus 2x cubed minus 7x plus 1, and that's our polynomial function, all right? This means that we have a degree 4 polynomial, so we will have a total number of roots, or zeros in this case, total number of zeros equal to 4, all right? Now, the number of real zeros, we're always going to have to get off of the graph, all right? So, the number of times, or I guess, let's put it this way, the zeros that appear on the graph. All right, because they can have multiple multiplicities, right? We could have x equals 1 be a 0, but it could bounce off the graph, and so it has a multiplicity of 2, all right? So the zeros that appear on the graph, so just count the zeros on the graph. All right. Now, for the multiplicity of zeros, let's look at some examples of what they look like in the graph, all right? So we know that if a function, let's say it goes like this. Oh, I don't want more than one on this one. We're going to go like this, okay? There is a 0 at x equals -1 for this function, all right? So x equals -1 is a 0. This 0 has a multiplicity of 1 because it purely just crosses the x-axis, all right? So that means the factor of this 0 might be x plus 1, right? And it's just raised to the first power, okay? Now, if we come over here and get a multiplicity of a 0 that, say, that's not a very good one. Let's say it bounces like that. It looks parabolic, okay? So it just touches the x-axis, and mine didn't actually touch, but let's say it does. That 0, that means that's that multiplicity of that 0, multiplicity of 2, right? Or an even multiplicity, right? Now, like it could be 4, it could be 6, it could be 8. If we're identifying off a graph, let's go ahead and call it 2, or you can just say even, okay? Honestly, let's go ahead and change that. I think that that's probably more accurate. So even multiplicity and it's going to be 2, 4, 6, etc. Right? And let's say that this one, its related factor is x minus 2. It could be raised to the second power, okay, for example. Now, if we have a 0 that comes up, squiggles through, and then goes off, let's even have that one be a little bit more creative. Comes up, squiggles through, goes up. Okay, let's go like that. All right. So see how it flattens the curve, goes up, and then flattens out. It almost looks like it's going to shoot off in that direction. And then it comes back up. When we have a multiplicity like that, that means it's going to be an odd multiplicity greater than 1. So over here we had a multiplicity of 1. It's an odd multiplicity, it just crosses, right? But when it squiggles through like that, that means it's an odd multiplicity that's going to be greater than 1, all right? So an example of this, for example, this one is at x minus 2, so x plus 2 is the related factor. So as an example, this could be raised to the third power, okay? It could not be raised to the first, however, because